and reliable, it lacked the necessary thrust. The F-16XL was equipped with this engine, and if the F-36 also used it, its performance would not be much different from the F-16XL that had already been eliminated, unable to meet the conflicts of advanced fighters in the future. Therefore, it was highly likely that the U.S. military would use the F-135 engine of the F-35. The official answer was given. The Air Force finally chose the Pratt Whitney F119 engine, a lower-cost version for the F-36, an engine already equipped on the F-22 and currently one of the most advanced engines in operation. If used successfully, it was estimated that the F-36 would reach at least Mach 2. Restarting production of this engine would also benefit the maintenance and upgrading of the F-22 later. In terms of flexibility, the F-36 was expected to use a large wing design, providing fast-turning ability and excellent maneuverability for the aircraft. However, the Air Force said, although the design focused on maneuverability, the F-36 was a lightweight, low-cost fighter jet, not possessing strong combat capability, mainly aimed at beyond visual range attack capability, reducing cost compared to other fifth-generation aircraft. The F-36's design did not focus on stealth capability. This was not entirely bad because it avoided the worry of external weapons affecting stealth capability. The large wing design also had another advantage. It allowed for more weapon hardpoints. For example, the F-16XL, although eliminated in the competition with the F-15E Strike Eagle, had many similarities to this design. In terms of weapons carrying capability, the F-16XL had 17 hardpoints with a payload of up to 6.8 tons. The F-36 could inherit this number or even more, but exactly how many would need to wait for further reports. As for sensors, the F-36 was expected to use the advanced APG-83 AESA fire control radar and the IRST Legion pod system developed by Lockheed Martin, allowing the aircraft to search for and lock onto targets without using radar, destroying the target without triggering the enemy's radar warning. So with such configurations, could the F-36 become the new main force of the U.S. Air Force? In 2021, the U.S. military announced some details about the new fighter aircraft, expected to replace all F-16 before 2030. Due to the urgent timeline and heavy mission, all materials and technologies used for the new aircraft were those that the U.S. military was already using or had developed. Therefore, the new fighter jet would be a combination of all the advanced technologies the U.S. military had developed, such as the engine of the F-22, the wing design of the F-16XL, and existing systems. To save time and costs, the U.S. Air Force also announced that most of the aircraft's parts would be manufactured with 3D printing technology. The core of the F-36 project was the principle of high cost effectiveness. The main goal was to replace the F-16S that had served more than 45 years in the U.S. Air Force and become the Air Force's main force, combined with the F-22 and F-35 to form a flexible lineup. Therefore, the F-36 would not be the most advanced aircraft, as some media had said. In reality, it was a mid-range fifth-generation fighter playing a transitional role. However, this helped significantly reduce research and development costs. And with the experience accumulated in producing fifth-generation aircraft, the development cycle of the F-36 would be shortened considerably. With the basic configuration from existing designs or slightly modified modern designs, the F-36 promised to bring clear economic efficiency. According to U.S. analysts, the production cost of the F-36 would be less than half of the F-35. Although it lacked stealth capability, the other features of the F-36 reached about 80% of the F-35. Although many aspects had been simplified, the F-36 would still be equipped with the most advanced avionics to ensure effective combat capability. As for weapons, the aircraft would be equipped with a cannon and could carry many types of missiles. There was no official information yet about which missiles the F-36 could carry. One point to note was that even without stealth features, the F-36 would still be very difficult to detect by radar. In addition, the F-36 also had a weapons bay, allowing it to carry air-to-air missiles during air combat missions without needing to attack the ground. This helped save costs where necessary, while spending wisely on important points. However, a practical problem the U.S. military faced was that they had already begun researching sixth-generation aircraft, while the F-36 was expected to launch around 2030. If by then the era of sixth-generation aircraft had begun, then the F-36, a mid-range fifth-generation aircraft, would become obsolete. Although it could be classified as a fifth-generation aircraft, the F-36 lacked the stealth capabilities of this generation. Although the U.S. Air Force had proposed the plan to replace the F-16, information about the F-36 was becoming increasingly scarce. The U.S. military also avoided mentioning details about the project's progress. Most current information came from the media and military observers. Had this aircraft already begun development, or was it still only a project on paper? Perhaps we would have to wait for more information from the U.S. military. What do you think? Will the U.S. military use the F-36 to replace the F-16, or will it wait for sixth-generation aircraft to appear and skip the fifth generation? In the sky, weapons alone are not enough. Courage is the ultimate weapon. The story of the F-36 King Snake shows us one thing. Power does not lie in absolute technology, but in strategic vision and wise choices. If you found this video useful, don't forget to like, subscribe, turn on notifications, and share your thoughts in the comments below. I'm Hi. See you in the next video.